Hi, I'm Gary Kinghorn. Welcome to this Bright Talk webinar presented by Forward Networks. We appreciate taking time out of your busy schedule to join. And to make the best use of your time, I want to keep this to about 30 minutes and keep it fast-paced and educational. As a heads up, assuming we have time at the end, there's going to be a live demo, which on a live webinar can always be a bit of an adventure. So there's also a question panel and a feedback pane if you guys want to ask questions. If there's time, I'll try to get to those towards the end of the presentation. But anyway, intent-based networking is a rapidly emerging new technology for providing greater automation and insight to highly complex networks. As the press and analysts and other vendors are starting to describe this vision, as is usually the case with any new technology, it's easy for customers to get lost in the hype and confused on the reality of what is really available to solve real-world problems. Hopefully this presentation will clear things up and help you identify what can really be leveraged today and what benefits can really be achieved. So what is intent-based networking? The term was probably first coined by Gartner Group as a vision for what they believed was the ultimate in network automation, although no real implementations existed at that time. But already a couple of different groups were researching and developing improvements to network automation as an evolution to earlier automation technologies like software-defined networking, and they developed real solutions along the lines of the intent-based networking vision. The four founders of Forward Networks, in fact, were PhDs from Stanford that did early research on software-defined networking and OpenFlow, but saw limitations to automating the management of networks beyond what SDN could address, and so they began research in this area that became intent-based networking and Forward Networks. So intent-based networking starts with the fact that the network team or the business has a great deal in mind of what they intend for the network to do. This may be in high-level business terms, in people's heads, or not even written down. It can come from security requirements, compliance needs, business objectives, or even specific technical requirements for individual applications. Naturally, intent's going to change rapidly over time, is never fully documented, and when people leave the company, whatever expertise might be in their heads goes with them. This can lead to very brittle and very much less agile networks. So at a high level, think of intent as really the collective intelligence held organizationally of what the network should be doing. And then intent-based networking aligns a one-to-one mapping of intent to the network design and its resulting behavior. That's the ultimate vision, a rapid alignment of business objectives and policy intent to the network design and configurations and implementation. This can make your network very agile and always up to date with current requirements. The challenge really arises, though, that intent is currently represented by a great deal of high-level intelligence and requirements that are broadly stated, and network configurations and policies are built with extremely low-level and arcane directives and statements by comparison. They really only apply to the specific device, and looked at on a device-by-device basis, it's very hard to imagine what the overall behavior is across an entire network from this low level of detail. So there's a huge gap between the various degrees of intent and actual network implementations. We've been coping with this problem since the first two computers started talking, and the business impact can be overwhelming. One of the first challenges that has to be addressed is how do you represent the language of intent in your system? How do you converge on this mapping? And we'll get into to that in a little bit. But first, to break this problem down, I want to think of a few specific aspects of intent-based networking and this one-to-one mapping. If you want to push your intent into the network, it requires translation of the intent in whatever form it's represented into these detailed network configurations, connections, and commands to each of the individual devices. So we call this translation. Or maybe you can think of it as enforcement, as in enforcing your intent into the network. Going the other way, if you want to ensure that your current network design is in complete alignment with your intent, I call that verification. And then there's a third process where I've identified that there's some misalignment, some error, or a policy violation in the network, and I have no idea where or why. There should be some sort of intelligent diagnostics and analysis capability to discover what the issue is and how to resolve it to bring these two things back into alignment. And I call that process remediation. Now I'll ask a question to get you thinking. Which of these is probably the hardest? If you were tasked with implementing these for your company, which one would you tackle first? If you want to be on record, you can drop your answer in the question or comment window, and I'll circle back around to answer later on. Okay, so networking teams have been doing all this stuff for decades based on intelligence, brute force, and a lot of late nights. But intent-based networking is really about automating these processes now as much as possible. If it took weeks to isolate a network configuration error to develop a fix and test it out in a non-production environment, can we compress that time to a few hours or a few minutes? Can we ensure there are no configuration errors in the network that could ever cause a policy violation? Could we implement changes to our network in nearly real time to keep up with every business initiative or new application requirement? And what would that mean to the business compared to today? Let's look at that as a possible representative network process. And sorry, this is a little faint, but we'll fill it in as we go forward. But the bottom line here describes a typical workflow from identifying a trouble ticket or a security incident or some sort of network outage that you have to begin to investigate, create a candidate change for. You do some pre-change testing. You have to review it with your peers to make sure any possible fix won't have any adverse impact on the network. You need to push this out to devices and then verify that the fix has really been implemented in the live network. Imagine, if you will, that you could automate the search process to diagnose the network behavior. You could drill down onto possible problems. You could present hypothetical scenarios as possible tests to further drill down on specific devices and quickly analyze the device configurations for anything that might be in error. This can be greatly accelerated through the intelligent query and search capability inherent in a strong intent-based networking system. Once you've got a possible change in mind, you can start to automate your pre-change testing. Will this change really work? You can simulate configuration changes in a system and ensure that they're correct and that all the security impacts are in place before rolling them into production. So this can shorten the amount of time for testing if you can predict the impact of a change to all the other existing requirements that you've got in place. And then once you've deployed the change to the live network, you can very quickly do some post-change verification to again reevaluate that the change is fully in place in the live production system, and you can reduce the likelihood of going through another change window very quickly, because a lot of errors do crop up when these deployments are done very quickly and in haste with a minimal amount of testing. Okay. Little bit about verification too is good to describe at this point. And that is, verification is different than testing in the sense that testing will test a certain number of specific scenarios, probably in an offline lab environment, different from production. It's looking at a specific set of traffic or traffic types or conditions in the network, and is not very thorough. Verification is actually almost a reverse design analysis where it probes your network design and configurations and looks for scenarios that could cause a policy violation, that could result in errors down the road, and is really an analysis of the design rather than a specific test, if you will. Verification methodology has broadly been applied in fields like software engineering, chip design, and so on, to ensure that designs are correct. But because of the scale and scope of network and network policies, hasn't been able to be applied until now. And now I'm going to get into a little bit about how we are able to implement verification in our system. Okay, so as I've described, that whole accelerated workflow of changing, analyzing, and deploying network updates and network configurations sometimes is called Network Operations 2.0 or NetOps 2.0. And we can describe that, how that's done in our system. But first, let me answer my question from earlier about which of those different phases of intent-based networking is the most challenging. If you said translation was the hardest, you're probably right. There's a lot of really interesting things that we can assist with, especially putting together a language model for representing policies and being able to isolate which configurations are aligned with the intent statements. But in general, some degree of artificial intelligence is probably going to be required to map high-level intent into that arcane network directives, with some human assistance probably still required today. However, we, especially in our system, have nailed this intent-based verification and remediation process, which closely matches our search and verify capabilities. We can look at the entire network and quickly determine whether it matches the intent or not, and where the discrepancies can be isolated. So search and verify generally go hand in hand, and depending on whether you need to verify a design or search for a root cause once you notice an issue. Okay, so in our system, how is this being implemented? First of all, it starts with us gathering together all of your network information in terms of the configuration, details, and state information from each of the network devices. And this begins to lay out a topology of your network and sets the stage for us to do a much deeper analysis. And again, this could be thousands of devices, you know, on a firewall, thousands of rules per firewall. This can quickly be you know, very overwhelming and represents a very, very large database for very large networks that we are pulling together and organizing. Then we have our own data model of how that network will perform and what its behavior is going to be. We do this in a very vendor agnostic method, and we have actually a deep understanding of each of the devices and how they will behave from each vendor. We have our own internal labs where we're constantly testing network operating system updates and releases from each of the vendors that are supported, and how changes to those devices will actually behave in a live network, even though we're doing it in a software model in our system. So on top of this software model, we then apply what is, you know, now recognized as a very revolutionary mathematical or logical algorithm to analyze what packets could possibly traverse the network and cause policy violations, and begin to analyze that network and do that verification step. This research was done by one of our founders and is called header space analysis now, is the technique for walking generic and sample packets through a network and trying to analyze where policy violations could occur according to the current design of the network, as we have in our database and model in our system. So then on top of this, this system, this infrastructure, and this mathematical algorithm, we can build specific apps and user interfaces and use cases, as I've described earlier, like search, the verify, and predict, into a web-based user interface. And we even have an API that you can build our analysis platform, our automation into your own applications, into your own dashboards, into your own network management systems very easily, and begin to pull and leverage in all of that data and results that we've been that we can enable. And this then whole system, as available from Forward Networks, can be run either on premises in your own data center, where you hold on to the data and run the virtual machines that run the system, or we run it as a cloud-based hosted application, and we manage that all for you. So multiple ways of deployment, but it's very simple to deploy, very non-intrusive. A lot of people are getting up and running very quickly and analyzing their environment within hours, certainly. Okay, so picking up on what some of the other vendors are now talking about, they've recognized that we're describing what we're doing as some sort of mathematical model and these analysis techniques, and they are now saying as well, oh yeah, we've got a mathematical model too, but as defined with this header space analysis and based on this software model of a mathematically, behaviorally correct network model, it's largely not true and contributing to a lot of the FUD out there. So be careful when you do hear this term now, mathematical model, from other vendors. And as companies jump into this space, you want to make sure that you have, a multi-vendor, very non-intrusive, agentless solution that will work on existing brownfield networks without upgrades or new hardware required and can operate at scale. And some of these last few points that we see are generally separating us from other vendors in this market. So I'm going to check and see if there's any questions from the audience yet. A couple things that have come in. How is intent represented in your system as it differs from what's in the engineering or network architect's head? That's something I'm going to get into as we jump into the demo, so hold on to that question. There's another question about, do you support virtual networks as well, or is this a physical solution? And the answer is absolutely yes. In fact, we support virtual network devices, visibility to virtual overlays. In fact, this is a great solution to solve some of the problems that have existed in software-defined networking, where you don't have that visibility and correlation between the physical underlay and virtual overlay networks. So that it's a huge boost to analyze network problems and issues and behaviors from that perspective for the first time. Okay, so that I'm going to jump into a demo, but first let me just summarize a few of the takeaways. That intent-based verification is really a key capability that's available today. It is in its infancy, for sure. It may take multiple solutions or a combination of some of the new solutions that are emerging, like ours, along with some traditional solutions like, real-time traffic monitoring systems to provide a full system. But it is possible today. The verification is really a key capability that you can do today. It's not testing, and it can really accelerate IT workflows, particularly for remediation and to verify network configurations against current requirements. So verification requires this mathematical software model that I've described, and any solution in this area really should be multi-vendor, non-intrusive, and agentless. So with that, I'm going to jump over to a demo. I apologize if this is because of some of the fine print in the demo. It's a little bit difficult to share, but I think at a high level, you'll see what's going on, and I'll describe the activity pretty closely and try to make this go quick. But first of all, I'm going to log into our system. And we have a very intuitive way of representing large complex networks. Here in this system, we've got essentially two data centers joined by an MPLS backbone. I can quickly scroll around and drill down on specific devices and analyze their configuration files or their state information, like their IPv4 tables or interface details. It's all very easy for me to jump in and understand from one centralized platform what is going on. But as I described earlier, the real power of this intent-based networking system is the ability to verify that your intent is aligned with your behavior. So in this portion of the platform, we have described our intent statements as a series of high-level rules or policies or requirements that have to be met. And I get errors when things are not according to my intent. And the intent language, although I won't go into much detail here, is very path-oriented. It describes end-to-end path behavior. It describes network wide requirements and activity, not device-specific details, which network engineers are traditionally tasked with dealing with. So these high-level rules and statements are much more intuitive, much easier to deal with, and provide a lot more power to describe intent, although it bridges that gap to getting a little bit closer to network details, network mechanics, and the language of IP and TCP/IP, if you will. Let me drill down into one of these error statements that we're getting and that's failing, and that is that traffic should be going from one source to a destination over the MPLS backbone through a particular firewall. That's not happening for some reason. Well, the results of any of my verifications is going to be a set of conditions or paths that result in this scenario. And here there are no paths because it's not happening. One very simple feature that we have in our system is to, first of all, decide whether this is a connectivity problem or it's a firewall security ACL problem. So I can remove all of the security rules and see if now the behavior is permitted, and in fact it is. So the result of this query, if you will, is the set of paths that result in this condition being true, and I can explore each of the paths and step through the network devices one by one. On the right side of this window, I'm able to see the behavior of the individual device, how it's affecting traffic flow, how it's configured to enable that behavior, and maybe drill down into more detail into the device-specific configurations. When I get to the firewall, I can see that the access control has somehow been misconfigured, maybe through some inconsistent rules, but the result is a deny all. So this is in fact where traffic is being blocked. So I can go in and fix that. It's almost a trivial fix, but I wanted to give you a sense of what the user interface starts to look like. But let's go back and do a sample search. Again, let's think of the situation where I'm getting some anomalous behavior or some potentially hacking behavior, intrusion behavior on my web application servers. So I want to make sure that any traffic coming from my internet gateway is indeed being delivered with HTTPS. So I'm going to check and see if any traffic is coming through on anything but HTTPS to my main public web application server, and I want to see if that traffic is being delivered. So that's a sample query I can check to see if indeed it's possible to hack into my web application servers. And in fact, I'm seeing, yes, indeed, there are available paths via other than HTTPS, which I now understand or by my intent, is a policy violation. So in fact, I can see that there's 32 specific paths. I can scroll through these, and in fact, they're mostly going through the same devices and certainly going through the same specific firewall. So when I go through and check this particular firewall, I can see that its access control list is indeed on level 4 destination traffic on not only HTTPS, but secure shell and port 80 HTTP. This is a policy violation I need to fix. First of all, I made sure that this is a really interesting policy that should be valid for all time. So I'm going to save this sample query that I've built as a verification check for all future releases and verification processes. So we'll add that. And in fact, now we can go over back to our Verify tab and see on this line where it says isolation, my new check has been added very easily, and it is indeed failing as we have noted. It's failing because traffic is coming through. And so we can step back out and let's go back and analyze that firewall. I'm going to drill down on its device state. I'm immediately brought to, out of all the complex firewall rules that could exist on this device, narrowed down to just the specific ones that are affecting my particular issue. And here in our system, I can actually go prototype that fix by making the changes that I think will fix the problem. I take out those two port access rules and save it to my sandbox. And now I can go back and again predict, is this going to have, this change I made, is it going to have any particular adverse changes to any other policies, rules, and applications that I've got in place? So let's rerun our verification step. And for this large complex network, it's going to take about 30 seconds. You're seeing this run in real time. And when it completes, you will see that we have a comparison of the prior state with the new state. So in this top rule, in fact, we see that the prior actual network state where it failed, it's now passing. And all the other things that were failing haven't been fixed yet. I can fix those later. But almost more importantly, things that were passing, that were requirements, are still passing. So I haven't introduced any adverse policy violations as a result of this quick change that I've made. So I can now go move to deploy that into production with a lot more confidence, and I've accelerated that change window process. At any time, I can go back and I can do a comparison of the changes between the actual network state and my sandbox or the new state that I'm going to push out to the network and do that comparison. So I've immediately started documenting not only prior histories of network configurations, but changes as they're made. And if I'm seeing new anomalous behavior, I can immediately go back and see which of these changes in which process might have introduced some of those new bad behaviors. So anyway, this has been a very quick demo on the BrightTalk channel that we've set up. We've got other little more detailed demos that you can see that describe other use cases and workflows. But hopefully that gives you an idea about some of the ways that we can accelerate these processes through this intent-based networking, through our software model, and the intelligent analysis techniques that we can apply. And so with that, I'm about at the 29-30 minute mark. I don't see any other questions from the audience, but I wanted to thank you for your time today. Once again, you can follow up with us at forwardnetworks.com. You can actually download a trial version of our software, or you can get a baseline version with some very preliminary capabilities that you can try on your network. And we'd love to follow up with you from there. So again, thanks for your time today, and we'll see you in future webcasts on our Bright Talk channel.